This is the third lesson in the Common Core Learning Standard 8G1, which is what is a rotation. The vocabulary today is angle of rotation, rotation, and center of rotation. Okay, so a rotation is a transformation that turns a figure around an angle. Unless otherwise noted, rotations are assumed to be counterclockwise. That's important to understand. When somebody asks you to rotate something, they assume that it's counterclockwise. Counterclockwise is also written like this, whereas clockwise is written like this. And counterclockwise is if you're looking at a clock. So if this is 12 and 6 and 3 and 9 on the clock, right? Counterclockwise is the direction that you would go that's counter to the way the clock moves. So the clock moves in this direction, that's clockwise, and counterclockwise is a way to describe circular motion that's in the opposite direction. So let's see, counterclockwise would go in this direction. Let's see, CW. Okay, so unless otherwise noted, rotations are always counterclockwise. If they want it to be clockwise, then they have to say specifically that they want it clockwise. Okay, so you can see the two figures here. We have A, B, C, and this would be D down there. And this was turned around the center of rotation E to make this figure right here. Okay, so the angle of rotation is the angle by which the figure is rotated. So I should have a which there. By which the figure is rotated. If this is not given, and the way you can find it is that you have to be given the center of rotation. So let's say this is the center of rotation right here. You draw a line between a point in the figure and the center of rotation. So there's that line. And the corresponding point in the figure and the center of rotation. Okay, so we draw a second line right here. And we make this into an angle. Okay, and we measure on a protractor. I put this here so we could sort of measure this angle by which, so C and C prime were corresponding points. I forgot to mention that. So I'm going to measure this angle. We're going to measure the counterclockwise angle, not the clockwise angle. So not the interior angle here. We're going to measure the counterclockwise angle because I haven't noted that this figure was arrived at with a clockwise rotation. So we have to assume that it's counterclockwise. So if you look at this little line right here, this would be 180 degrees. And these little tick marks here are tens. So 180, 190, 200, 210. It's about a 220 degree rotation. So the angle of rotation would be 220 degrees. Okay. If you wanted to rotate the other way, you could say the angle of rotation, so you could do 360 minus 220, which is 140. So you could also say this was a clockwise rotation of 140 degrees. So you'd have to specify that it was clockwise if you wanted to describe that rotation. Both rotations, either a counterclockwise rotation of 220 degrees, or a clockwise rotation of 140 degrees would arrive at the same figure. Alright, some properties of rotation is that orientation is not preserved under a rotation. So if you can see B is above and to the right of A in the first image. But if we look at B prime, it is down and it is below and to the left of A. Okay, so right there, those two vertices, the orientation of those two vertices are not preserved. Right, if you look at another pair of vertices, C is above and to the right of D in the first figure, and if I compare C, I'd have to go to the right, not by the same amount either. Actually, I'd have to go from D to C is what I did before, so I'd have to go down and to the left. So down and to the left, whereas from D to C on the original figure, I had to go up and to the right. Okay, so orientation is not preserved under rotation, but size is preserved. Okay, these two figures are congruent, which means that all parts, so every line segment, the length of every line segment in the figures, and this area of the figures are both the same. And another thing that's preserved is distance from a point on the original figure to the center of rotation. So let's mark that distance for a minute. Okay, so let's pick a pair of congruent points. Let's pick the C. Okay, so if I make this distance from C to E by connecting those two with a line segment, so let's call this distance D1, and I make another distance right here, D2, what we know is that D1 is equal to D2. Okay, we could do that with any of these points. I could do it with B. So if I connected here and here, we'd know that this line segment and that line segment are congruent. If I did it with A, so I'd have this and this. These are also congruent to each other, but not congruent to the previous line segments. And the same thing with D and D prime. Okay, if you're rotating a point, so let's say that I want to rotate the point 90 degrees. And remember, that's assumed to be counterclockwise. This is the assumption. It's assumed. Okay, so if I want to do 90-degree rotation, what rotate? It's a little hard to figure. I mean, it's easier to see that a figure has been rotated than it is to see that a point has been rotated. So I'm going to rotate this point, and it's not going to really look like it's rotated. But you may have found out in your investigations today that when you rotate a point, what you do is you take the old x, y coordinates and you flip the x and y coordinates around. So it would be let me see if I can write it. Let me write it so it's a little bit bigger here. To do it 90 degrees, you take the old x and y coordinates and you flip the x and y, so it will be y comma x, and you also make that first coordinate negative. So let's try it with A. Let's go -5, 4, -5, -4. That's what it was before. And then what you do is you switch those around. So that'll become actually it's -5, +4, isn't it? So we take -5, +4. We flip these around, so we'd have 4, potentially -5. And we also want to make the first coordinate negative. Okay, so this is A prime. It's been rotated 90 degrees. So it's -4 and -5. This is A prime. Okay? And the characteristic of a point that's been rotated 90 degrees is if you draw a line from the center of rotation from each point, this is a 90-degree angle. Okay, that's how you know it's been rotated, that that's a 90-degree angle. Remember, you draw a line from the center of rotation to the point, to each corresponding point. You make two line segments, and this right here is the angle that you rotated at. Since we rotated at 90 degrees, these two lines are perpendicular. Okay, let's say that I was rotating it 180 degrees. So I want to take A and rotate 180 degrees. Now remember, 180 degrees is two 90-degree rotations. So since a 90-degree rotation took your x and y and did this with it, made it -y comma x. Well, another 90-degree rotation would make it, you'd switch it around again, but you'd make this new coordinate would be negative, and that would be the same as the old one. Okay, so a 180-degree rotation would take your x and y coordinates and do that with them. Okay, so if someone just says rotate something 180 degrees, you don't have to do two 90-degree rotations. Just make your x negative and your y negative. So if A is -5, 4, I would take the opposite of -5, which would be 5, and take the opposite of 4, which is -4. I said make your x and y negative before, and what I really meant to say was take the opposite of what the sign is for your original x and y coordinates. So +5, -4 would be here. +5, -4 would be here. And if you can see, there's actually, so remember, the check is draw a line between the original point in the center of rotation and the new point. So this is A prime in the center of rotation, and this angle should be the angle of rotation, which we said it was. We said this was 180 degrees. Okay. And if you were to do 270, remember 270 is just an extension of your 90 degree. 270 is 3 90-degree rotations. So you would take whatever 180 is, flip it around, so negative y and negative x, but this time you make the first coordinate negative, or you make it the opposite of what it was before. So this is your rules for 180. You have your old xy, and you flip it around, but this time the first coordinate's positive and the second coordinate's negative. Okay, so if I wanted to rotate a 180 degrees, I would take negative 5, 4, and I would flip them around. I'd have 4, and I would take the opposite of my x-coordinate. So in this case, it might be easier to break it down. So my x-coordinate is negative 5. My y-coordinate is 4. Okay, so 170-degree rotation keeps your y-coordinate, but it just places it in the first position, right here, the value of your y-coordinate. And it takes your x-coordinate, takes the opposite, so the opposite of negative 5 is 5, and it puts that in your y position. So A, if it's rotated 270 degrees, would end up at 4, 5. It'd end up right here, A prime. And I can check that by connecting these points and noticing that that's a 270-degree angle of rotation. Okay, if we rotate a figure on a graph, so let's say that we want to rotate it 90 degrees. There's two ways to do it. Well, actually, doing it by sight's a little harder. It's easier to do it by vertex. So let's write down the vertices here. So A is going to be negative 4, 5. Okay, so A prime, remember a 90-degree rotation takes x, y, and it flips them around and makes the first position negative. Okay, so it takes your old y-coordinate, flips it around there and makes it negative, and it keeps your old x-coordinate but puts it as the y-coordinate. Okay, so B is negative 3, 3. Same thing here, B prime is going to take that, make it negative, and keep that old one like that. C is at negative 4, negative 1. And so it's going to, C prime is going to take this, make it the opposite of what it was before, and keep the old x but place it as the y. And finally D, since it is at 1, 6, D prime will be, let's see, negative 6, 1. Okay, let's graph these points with another colored marker here. So let's see, A prime would be negative 4, negative 5, right here. That's A prime. B prime will be negative 3, negative 3. Oops, that's B prime, okay. C prime is 1 and negative 4. That's C prime. And D prime is negative 6, positive 1. There's D prime. Okay, so let's connect these in order. A to B, B is to C prime, and then we do it that way, and then we do it that way, right? Okay, so this figure has been rotated using the center of rotation as the origin. Okay, and we can check this by let's erase a lot of this information here and just choose one quick check on this. So we want to connect two points that are corresponding. So let's try the D's. So if I connect D to the center of rotation, which is the origin, and I also connect D prime, you'll see that this is a 90-degree angle. Okay, so the orientation, again, with the rotation, the orientation is not changed. The orientation is changed, but the size is not changed. Okay, we have one more figure, and let's rotate this 180 degrees. Okay, with a 180-degree rotation, remember, it's like two 90-degree rotations. So what I would do is I would actually just keep my X and Y in the same position, but I would just make them both the opposite of what they were before. Okay, so let's write down all of our coordinates. A is at 6, 3. So A prime is going to be at -6, -3. B is at -1, -2. So B prime is at 1, 2. So I'm just taking the opposites of the original coordinates. C is at 3, -3. So C prime is at -3, +3. Okay, so A prime is at -6, -3. So there's A prime. B prime is at 1, 2. And C prime is at -3, +3. So there's C prime. Let's connect these in order. So A prime goes to B prime. And, oh, I forgot D. Whoops. So let's see, D. So D's right here. So D is at 4, 0. So D prime would be at -4, 0. Right, the opposite of 0 is just 0. So -4, 0 would be D prime. So A prime goes to B prime. B prime goes to C prime. Then C prime goes to D prime. And then finally D prime goes to A prime. Okay, so it's hard to see. This is a little concave area right here. But this figure has been rotated 180 degrees. Okay, and let me just do one more rotation of 270 degrees. So 270 degrees is taking the same idea. You're rotating it 3 times, 90 degrees each time. So if you want to work it out that way, you can, but you can also just try to memorize that a 270 degree rotation would just be a 90 degree rotation on 180 degrees. So sometimes that's the way I like to think about it. I know 180 takes my XY coordinate and it makes them -x, -y. That's easy to remember. I know another 90 degree rotation would take that coordinate and take the opposite of it and leave that coordinate the same, but write it as a different position. Okay, so this is the 270 degree rotation. It takes the XY coordinate and it takes the same Y coordinate but puts it as the X coordinate, and it takes the opposite of the X coordinate and puts it as the Y coordinate. So here's my 270. So let's write, so we know A, let's just write these down real quick. Oops, C and D. So A is at 6, 3. B is at -1, -2. C is at 3, 3, -3. And D is at 4, 0. Okay, so A prime is going to be at, so I'm going to keep my Y coordinate the same and take the opposite of my X coordinate, which is that, and switch them around. Okay, and B prime is going to be, let's see, take the opposite of, take my Y coordinate as the same and take the opposite of my X coordinate. C prime will be that, and D prime is going to be, say, put this as my Y coordinate and take the opposite of my X. Okay, so let's graph these guys. We don't need these anymore. 3, -6. Oop, that's really beyond. It's probably about right here. Okay, so that would be A prime. And B prime is -2, 1. C prime is -3, 3. -3 rather. And D prime is 0, -4. So there's D prime. So let's connect them in order. Here's my little concave bit right there. Okay, and that's the figure that's been rotated 270 degrees. So if I check myself, remember I can draw a line between the corresponding points and the center of rotation, and that should be a 270 degree counterclockwise rotation. Okay, so what you do need to memorize is that you need to memorize that a 90-degree rotation takes your x and y coordinates into negative y, and x becomes the same. 180-degree rotation takes your xy coordinates and just takes the opposite of both of them, but keeps them in the same position. And a 270-degree rotation takes your x and y coordinates, and it flips around, so it keeps your y coordinate the same, but it takes the, it takes the opposite of your x coordinate and does that with it. So it's really 270 and 90 degrees are sort of the exact opposite things are happening. You flip the coordinates around, but the other coordinate becomes negative. Okay, so that's these things you should memorize. All right, so that's the end of the lesson for today.